Saxon Algebra 2, Lesson 87. Oh gosh, I'm so glad this day has come. The topic of our lesson is slope formula. We are going to talk about this in relation to graphing lines. Our friend, y equals mx plus b, he is the guy that helps us graph lines easily, effortlessly, fluidly, right? This has nothing to do with trig functions. This is just old-fashioned graphing a line. We know that m represents the slope. We know that the slope can be positive or negative. We know that if it's positive, it's called the rise over the run. Sorry, my vowel got confused there. Rise. And we can use it to count up and count over. Sometimes it's negative, and then it's what I call the sink over the run. Sink means you go down. Run is always to the right. All right, and we know that there's that picture that I always talk about of the little person in the car riding up the hill or riding down the hill. Positive slopes go up, negative slopes go down. You've got to imagine, sometimes to me it looks like there's different pictures in different books, and sometimes it looks like it's a woman with like a top bun in her hair. Excuse me. And other times it's a girl with a ponytail. I love them both equally. I think the idea of a little person driving cars up and down our graphs is spot freaking on, and I love it very much. So that's what we know about slope. And we know that if you see a picture of a graph, you can count from one point to the other point using this rise over the run or sink over the run, and you can figure out the slope. Spoilers, that's what's going to change today. But let me just talk a little bit about this number. This is the y-intercept. Just a second, I forgot to write y-intercept. It's kind of critical, right? The y-intercept. This is the point at which our line crosses the y-axis. Super easy. There's no calculation. Oh, sorry. I'm suddenly yawning. It's because I'm talking. I haven't been talking for a while. All right. So the y-intercept and the slope are the key players in graphing linear equations. Y-intercept, there's no drama. Slope is the one we're going to turn our attention to today, obviously. Okay, let me just show you the picture in the book so you know what I'm talking about. John does this tedious thing where if we're trying to figure out the slope from this point to this point, we have to count. In this point, it would be the sink over the run, right? We generally move from left to right. We would go down and then we would go to the right, and we'd have to count tediously. I hate that. No more. Here's our formula. If we are given 2 points, let's call the first one x1, y1, and the second one x2, y2. Normally we put commas in between those. I'm not putting commas because the comma will look like a 1 and it'll confuse you. So just pretend there's a 1 in there. If we have 2 points, we can find the slope like so. There it is, ladies and gentlemen. That is what we call the slope formula, and we're going to use it a ton so that we don't have to point at little pictures and try to count squares. Ew, no. This formula is fairly straightforward and easy to use. Here are my 2 tips. Label the points. I'll show you what I mean by this as we work on, but it's easy to get turned around because there's x1s and y1s and x2s and y2s, and it all starts to jumble. We have to take them out of order, right? We take the 2s before the 1s, the y's are on top. Oh, it just gets horribly confusing. So it helps if you label your points. The other thing is use buckets. Anytime there's a minus sign in a formula, it's a really good idea to use buckets, especially because our points that we're plugging in can also have negative values, and quite often do. So once we start having a bunch of minus signs flying around, that is always a dang it, use your buckets tip scenario. So these are my 2 tips that I will play out. All right, how many examples are there? Don't you always want to know? There's 2. Example 87. Point 1. Use the slope formula. Oh, it's that. Make sure you memorize this, P.S. Don't just sort of let it float into your brain as you do your homework. Actively memorize it. Cover it up and test yourself. Use the slope formula to find the slope of the line that passes through, and now John gives us 2 points. The 2 points are 2, -5. There's the comma that we're used to. And -3, 7. Note the negative values. We'll remember to use buckets. Okay. So I'm not going to rewrite my formula because I've got it right there. I mean, we don't have to be crazy about this. So I'm going to use this formula and these points. I'm going to plug them in and I'm going to solve for M. It's going to be super fun. All right, ready? Now, my first tip is to label the points. This is what I mean. It doesn't matter which pair are the 1s and which pair are the 2s. It will work out either way. What is more important is that the 2 numbers in the same parentheses have the same number. That's important. And obviously the first one needs to be X and the second one needs to be Y. I usually just do it like this. I just put the 1s first and then the 2s because that feels really logical to my brain. But next time I'll reverse it. I'll put the 2s here and the 1s there just to show you that it works either way. Now we set this up with our buckets. Now we plug in. Go carefully. Y2 is 7. Y1 is -5. X2 is -3. And X1 is 2. I'm yawning so much. Trust me, I'm not bored. I love this. I could do this all day. Now we have to simplify. 2 minuses make a plus. 7 plus 5 is 12. -3 minus 2 takes us further down in the hole. We're on the ladder in the meadow, if you remember that. That is -5. And so the proper way to write this is to bring that minus sign up and float it. So our slope is -12/5. That's the right answer. Remember that when we're doing these calculations, fractions are fine. It doesn't make anything any harder to have a kooky fraction like that because we're not actually going to graph it. We're just calculating. Okay, beautiful, right? And then let's do the last one. I guess I'll flip and I'll rewrite. I want you to practice right now writing that formula. I'm going to write it. Cover it up if you can still see it in your own notes. Cover it up and try writing it right now. I'm going to hide mine and let you have a chance to work. I'm going to count to 20 and then I'll show you. Ta-da! That's the formula. Okay, so here's our problem. Example 87.2. Use the slope formula to find the slope of the line that passes through -5, 100 and -33, 57. Oh, the numbers have gotten bigger. John purposely made the problem crazier to make the point to you that it doesn't matter. If the numbers are crazy, it really doesn't affect our calculation very much. It's NBD. The other thing I want to point out to you is that in this lesson, all we're being asked to do is use this formula to calculate the slope. Later, we'll use this as one step in a bigger problem. So we're just taking baby steps into this process. Okay, so here we are. Now this time I said, let's make these the 2s. Like I said, it doesn't matter as long as the numbers within the pair match. And what I mean by that is if I had x1, y2 or x2, y1, that would be a problem. The numbers in the same pair have to have the same number subscript. Okay, now we're going to plug in m equals buckets, my other hot tip, right? Labels and buckets are my two tips. All right, y2 is 100. y1 is 57. x2 is minus 5. And x1 is minus 33. Okay, now we simplify. 100 minus 40, see, I tried to say the answer. 100 minus 57, pause, think of it yourselves. You're right, it's 43. I started to say it out loud. Minus 55 plus 33. 28, am I right? And in this case, we're all done. We don't have any minus signs to straighten out. If we did it the other way, we would get two negatives and they would simplify to the positive, if that answers any questions for you or makes you feel any better. This is a super easy to use, user-friendly, very common, useful formula that we're going to use over and over and over again in our lessons. So memorize it. Yay! That's the end of 87, you guys. So fun. Thank you. Bye.